Good morning, students. It's been quite a long time since you've heard my voice or since I've been able to see you guys. So I decided to throw together this short, quick video over the diagrams that you are going to look at today. Just to give you guys a heads up, I plan on having this assignment and maybe one or two more, and that's it for this semester for evolution. So keep up all the hard work, and hopefully we can get through this week and next week quickly and painlessly. So if you look at this diagram, you should have your diagram open. I'm sorry, document open. I'm just going to go through these few diagrams. There are three diagrams to represent how humans have, or humanoids, our ancestors have evolved over time. You guys did your research projects. The research projects were in order of evolution over time. And now we're going to look at this in a chart form. This first chart, I like to start with emphasizing up here at the top is millions of years ago. So over here is 8-9 million years ago, and then over here is present day. As you make your way down on the chart, you can see in this cladogram or cladogram where different branches of ancestors branched off. So for example, about 7.5 million years ago, the branch that led to chimpanzees and bonobos branched off. Remember, they are not our direct ancestors. We shared a common ancestor with them about 7.5 million years ago. And then about 1 million years ago, you can see this is where chimps and bonobos became two distinct different species. Moving down then, what I like about this diagram is it shows all of our human or hominoid ancestors, starting with Sahelanthropus tacadensis, and it shows about how long this species survived on Earth. So if you go back up and look at the top, this species was on Earth for probably about, 300,000 years ago, and this was about 7 million years ago. And then it shows where common ancestors branched off and why. So these little nodes will tell you. So for example, when we branched off from the not chimp, not bonobo ancestor, we started to get adaptations for walking bipedally, and our canine teeth started to get a lot smaller canine teeth, okay? As you go on, you're going to see different branches, and these created different hominoid ancestors. One thing that's interesting to see is that as our canines got smaller, our cheek teeth and jaws got bigger. That means our molars got a lot bigger. And that's probably because our diet changed. We probably started eating a lot of nuts, things that we needed to use our bigger teeth, our bigger molars to crack and grind. So a lot of nuts, a lot of grains. And then this continued, and you can see here's all of the Australopithecus ancestors over time. Um, as we developed more, we get into Paranthropus. This is like our really larger, as you can see by this little guy, our larger, more robust ancestors, and they were more robust because they had massive jaws and massive molars for the diet that they ate. And you can kind of see that in this picture here, how much bigger their jaws and teeth were. And we keep going, and eventually we get down to Homo habilis, Homo erectus, Homo neanderthal, Homo heidelbergensis. And one of the things you should see, or a trend, is that over time, from here to here, it's how our brains started to get a lot larger. And as our brains started to get larger, we started to make more sophisticated tools and whatnot. And then also our teeth started to continue to change. At the end, it gets a little bit messy here at the bottom where Homo sapiens split off and who we are, quote unquote, directly related to. This is kind of like a different way of viewing the evolution at the bottom. And it's not one distinct branch, it's a branch from Homo erectus. But then Homo neanderthal, Homo heidelbergensis, and Homo sapiens are all kind of branching off of each other because we're not 100% sure who came from who. Did we intermingle? Did we interbreed as different species? The only thing is that we are currently the only species that is still present on our planet today. That's the first chart. The second one, I really like. Once again, if you look up at the top, it goes from 7 million years ago until today. And this, it emphasizes, I like because it says this is when we diverged from chimpanzee, what became chimpanzees and became bonobos. And I also like over here, it talks about when we started walking on 2 feet, when we created fire, and when we had stone tools. What I like about this diagram is it shows us in this diagram, like I said, in gray are the important developments, in orange are what they call the pre-human primates. So possibly our potential ancestors, a lot of them are Australopithecus, and their different variations. And then what eventually became humans, or in this case, what they're considering humans, or anyone in the Homo genus. Okay. Um, what I like about this diagram is it does a really good job of showing you overlap, and meaning overlap of when different species were alive at the same time. And what you can see when you look at this is during probably from about here all the way through here, look how many species actually existed at the exact same time. So at one point in here, we had 1, 2, 3, 4, 5 different hominid species on Earth at the same time. Meaning it wasn't just like a linear one led to the next, which led to the next, which led to the next. It's more like a bush or a branch of our ancestors who were all evolving in their own way and changing based on their environments, but they were all present on Earth at the same time. And if you even look at more today, we see that Homo sapiens were alive at the same time as the Hobbit people, Homo florensis, and Neanderthals, and Hildebrandsensis, meaning we are probably some type of combination, and maybe possibly a little bit with Homo erectus. We are some type of combination of all of those things, slash we possibly interbreeded with those different homogeneous hominoid ancestors, which is why we might contain some DNA in common with those other hominids. The last chart is probably my favorite. It combines kind of the other three together. The one thing though that's confusing is it goes opposite in order, and this actually annoys me. I'm not really sure, but here is 7 million years ago, and then here it is present day. Once again, I like this chart because you can see, it says right here, temporal ranges. You can see the overlap or the range of time that these living things inhabited our world. And then finally, I want to point out inferred relationships. Inferred relationships on this chart means we kind of think that one thing possibly mixed with, was related to, or came from another thing. So for example, if we're looking at this up here at the top, you can see they think there's some type of ancestor that led to Homo rudolphus or Homo habilis up here, and then possibly Kenyanthropus platopus. And it's really, really, really kind of messy in here, but we're thinking that there might be missing links in there, or we're thinking that these organisms maybe interbred or intermingled and led to the organisms further on the left. One of the things I also want to point out is there's a lot of question marks in here, especially what's leading to humans. So we're seeing here that Homo ergaster or Homo erectus, something before maybe Homo erectus, that's this one, and then Homo heidelbergensis. These were the three ancestors that kind of led to humans. And we also know, which isn't really shown on this chart, that there probably should be a dotted line between Homo sapiens and Homo neanderthals, because we know that we interbred with them as well. But I like this chart because it's kind of mentioning that we think that these different hominids had relationships or relations with one another to create our more modern species. The other thing you have to keep in mind with these charts is that they are constantly changing over time. And the reason that they change is every time there's a new hominid discovery, we have to add to the charts or possibly take away from the charts. And that's why it's so exciting every time we discover a new hominid ancestor, a new species. It's a really big deal. You make a lot of money, you get to name the new ancestor, and you get fame as a paleontologist or an anthropologist. So discovering a new hominid species is a really, really, really big deal. So now that we've kind of gone through this, you guys are going to answer based on my lecture and based on the diagrams, some questions about each diagram and how things have changed over time. And then at the very end, this is a horrible example of evolution. It's a bad example. Yeah, it's the most common one we see. So I want you to explain why this is an inaccurate view of evolution. And then in the final box, you are going to put a picture of what you think is a better representation of human evolution, not this linear straight line. Okay. If you have any questions, please let me know. I really, really, really miss you guys. And like I said, we have this assignment and maybe one or two more, and we are done for the year. Thanks, guys. It was great to talk to you, and I hope to talk to you soon.